Good afternoon, ladies and gents. We are going to continue this session on the paper that we've started during the course of a week. And this was a paper 4 from 2003, when we will continue with question 3A. Question 1 and 2 is on the previous YouTube. Okay, now there's a set of information given. There are two sets of road signals on the direct 12-kilometer route from A city to B town. The signals say either go or stop. The probabilities that the signals are go and when a car arrives are shown in the tree diagram. And then they ask us to copy the tree diagram and complete it. Okay, so what do we have to remember? That if two legs or several legs start from the same vertex, they will add up to 1. So we've got to complete this, and so 1 minus 0.4 would give us 0.6. There we go. And 1 minus 0.65 would give us 0.35. And 1 minus 0.45 would give us 0.55. And we are done with that first bit. Good, let's continue. Question B1 says, find the probability that the car driver finds both signals are go. So the probability that we are go, and we can see here that go and go, so we will just add this up, or actually multiply it, so it's 0.4 times 0.65. If we do that on our calculator, we'll get 0.26. Okay, let's go to the next one. The probability that, find the probability that the car driver finds exactly one of the two signals is go. So it is go and stop, or stop and go. So it's a probability of go and stop, or the probability of stop and go. So let's quickly fill this in, and we have the go as 0.4 times stop, that's 0.35, or is always plus and is multiplication, so 0.6 times 0.45. If I do that on my calculator, 0.41 is the answer. Okay, let's see the next one. The next one says, does not find two stop signals. Does not find two stop signals. So we are first going to find the probability of stop and stop. And then I'm going to subtract it from 1, because that would give me the probability of not stopping, not having two stop signals. So stop is 0.6 times 0.55. Now we will subtract it from the 1. So it's 1 minus the stop would be the probability of not stop. Okay, that little dash next to it is stop not. It's not stop. Okay, so if I do that, it would be 1 minus, and the stop times the stop was 0.33, and the result would be 0.67. And we leave it as that. Okay. Good, let's move on to the next question. Question 3, C1. So with no stops, Damon completes the 12-kilometer journey at an average speed of 40 kilometers per hour. Okay, so there is his average speed, and the distance is 12 kilometers. Okay. Now they ask us, find the time taken in minutes for his journey. Okay, so we want to find the time taken in minutes. So time, we want to find time, and it must be in terms of minutes. Good, so we know that speed times time equals distance, but I've got kilometers per hour, kilometers, and I want my answer in terms of minutes, so I need to change this speed from kilometers per hour to kilometers per minute. And I'm going to use a unit converter. I know that 1 hour is the same thing as 60 minutes. If I do that, hours and hours can cancel out, and now my speed would be 40 kilometers over 60 per minute. And if I do that, well, I will keep that as it is and just do the calculation before I do the calculations. So sorry, speed times time equals distance. I know my distance is 12 kilometers. My speed is now 40 kilometers over 60 minutes times time equals my distance. If I solve for time by dividing on both sides by 40 over 60, I will get 18 minutes, because kilometers and kilometers will cancel out and it will leave me with just minutes. Okay, good. Let's go on to the next one. Number 2 says, when Damien has to stop at a signal, it adds 3 minutes to his journey time. Calculate his average speed in kilometers per hour if he stops at both road signals. So he stops at both road signals. That would give me 3 times 2. Okay, because each one will give him 3 minutes. And there's two stop signs, so it would give us a total of 6 minutes that we've got to add. Okay, so we know that his total time plus the 6 minutes. We do know that the distance is still going to be 12 kilometers, and I know that we have speed times time equals distance. Okay, so we need to find his new speed. So speed times time would now be 18 plus the 6 minutes. That would give us 24 minutes. So let's just write it down. Time would be 18 plus the 6. That would give us 24 minutes. And we can start calculating it. Okay, now, sorry, we want our, do we need it in something? Yeah, we need it in kilometers per hour. So 24 minutes, I've got to change it to something in terms of hour. So I know that 1 hour is 60 minutes. Minutes and minutes will cancel out. If I plug that onto in my calculator, I get 0.4 hours. Okay, now we can do that. Speed. We don't know what the speed is. We do know what is for hours. So it's 0.4 hours equals this distance of 12. I divide on both sides by 0.4. That would give me speed equals 30 kilometers per hour. And that would be my answer. Okay. Good. Let's go on to the next question. Question D. Let me just get my paper here. Elsa takes a different route from A city to B town. So it's a different route, okay? Not the same. This route is 15 kilometers and there are no road signals. Elsa's average speed for this journey is 40 kilometers per hour. Find the time taken in minutes for this journey. So we want the time, and the time must be in terms of minutes. Okay, now let's start going there. Okay, so we know that 40 kilometers per hour was her speed. So 40 kilometers per hour and times the time equals the 15 kilometers. Okay, so if I solve for time, that would mean that I have 15 kilometers divided by 40 kilometers per hour. Kilometers and kilometers will cancel out, and I will have time as 0.375 hours. But we do not want our time in terms of hours. We want it in terms of minutes. So I need to do some work here, multiply it by my unit converter. So I know it's 60 minutes over 1 hour. An hour and hours can cancel out. If I do that, I get 22.5 minutes. And that's the answer. Okay, good. So let's see the next question. The next question reads, the probability that Damon takes more time than this on his 12-kilometer journey. So remember that the 12-kilometer journey had the stop and the stop. So we will have to find that, the probability that it's stop and stop. We know that that would be 0.6 times 0.55. And if I calculate that, it's 0.33. So the probability that we'll take more time on the 12-kilometer journey is 0.33. Or basically a third. Okay, good. That leaves us with question 4 to go. Let me just turn the page here. Now I have done this grid so that we can save a little time. But with your question 4, it gives you a lot of information. Then it says using a scale for 2 centimeters to represent 1 unit on the x-axis. So that would be 2, 4, 6, 8. And on my x-axis and on my y-axis, it says 2 centimeters to represent 4 units. So 4, 8, negative 4, negative 8. And then they give us some values. They say draw the x-axis for negative 4 to 4 and the y-axis for negative 8 to 8. So let's see. So I'm happy there. I've done what I should be doing. Okay. Sorry, I've done these wrong. It must be negative 1, negative 2, negative 3, negative 4, and 1, 2, 3, and 4. Okay, now my grid looks a lot better and I'm happier. Okay, now we've got to draw the curve. So I've done the plots. I've plotted all the little points with little tiny x's and in exactly the right places. And then I will use one smooth motion to draw my graph. Okay, and that's it. That gives us a couple of marks and I'm happy with that. Okay, now the question B says use your graph to solve the equation fx equals 0. Okay, so where would fx be equal to 0? So that would be B, fx equals 0. I should actually write on a separate piece of paper here so that we can use our grid. So fx equals 0. Okay, so that means where would y be 0? Y would be 0 where the places where it cuts the x-axis. Okay, so on my grid, I'm going to check that. So it probably negative 3.6. If you use graph paper, your answers would be a lot better. It will definitely cut there at 0. And I would say about 3.5 on my grid. Okay, about 3.5. It could be about 3.6 as well. And that's the places where the fx, where the graph would be equal to 0. So let's just put that in down as fx. Okay, and that was question B. Question C. On the same grid, draw y equals gx. Okay, and for this interval between negative 4 and 4, and it does include negative 4 as well. Sorry, that must be a 4 there. Where gx is equal to x plus 1. Okay, so x plus 1, I know that it will cut the y-axis here at 1, so that's 2, it's over there, and it will be there at negative 1. It's a positive gradient. I'm just going to use the straight edge to draw it. And there you go, that's the function gx. So I'm done with number C. Okay, then number D, they ask us, write down the following values. G1. Well, we do know what is G. G is x plus 1. What it means is I'm going to substitute 1 into the place where there's an x. So it must be 1 plus 1. That will give us 2. So that's number I. 32I says FG1. So I do know, sorry, let me move it up. I do know what is that. G1 is equal to 2. So that means actually I have F2 to solve. Where would the function f be equal to 2? And if I look on my grid, f2, that would give me negative 8. So the answer would be then negative 8. So for question 3, it says find G inverse of 4. So I'm going to start off by saying y equals x plus 1. First, I'm going to find the inverse. So it's to subtract 1 on both sides. So x equals y minus 1. Sorry, I'm just moving my page up there so that we can work a little faster. Then I'm saying y inverse equals x minus 1. I don't want x there. Where the x is, I'm going to substitute 4. So G inverse 4 would be 4 minus 1, and the answer is 3. And that would be my final answer. Okay, let's go for 4. It says the positive solution where fx is equal to gx, the positive solution. So that would be where the two curves are going to intersect with one another, and we're only looking at the positive side. And if I look at that, that would be the value, and I would say about 3.8, maybe 3.8 on my grid. Okay, yours could differ a little bit. Okay, good. That would conclude the first bit here for C, or for D. Now let's have a look at E. For E, they ask us, draw a tangent at the function fx where x is equal to 3. So where x is equal to 3, and I'm going to draw a tangent there. A tangent is a line that touches the curve at only the one space, and I'm just going to try to use a different color there so that you can see this tangent. Okay, so that's that red line there. I'm just going to call it tangent. Okay, now we need to find the gradient of that tangent, because they say and calculate an estimated gradient. So if I'm looking at that, we need to look at 2 points. So I would say the point 2.5. So 2.5 and negative 8. And I have a point 4.1 and 0. Okay, so this would be question E. Okay. Now the gradient is m equals delta y over delta x. That would be negative 8 minus 0 equals 2.5 minus 4.1. And I need to plug that into my calculator. Just get my calculator from my bag. There you go. So negative 8, negative 0, and 2.5, negative 4.1, and that would give me a gradient of approximately 5, and that is my answer. Your gradient might look different, your values might look different, but it would be in the positive direction and approximately that value. Good. Let's go on to question 5. Okay, the first bit is they say calculate the area of an equilateral triangle with sides 10 centimeters. Okay, so I've drawn an equilateral triangle there. My sides are 10 centimeters. And I've thought about this problem. There's probably a few ways that you can solve it. You could still do half base times height. A half base times height. And then you had to find the perpendicular height. And use Pythagorean theorem to do that. And then it struck me, well, why not use the whole pieces in A? We can use both, either, okay. So the area of any triangle is a half BC sin A, so it's a half. My value of B is 10, my value of C is 10. If it's an equilateral triangle, all three angles would be equal to one another, so it would be sine of 60. If I plug that into my calculator, let me just turn the page here and do that calculation quickly. That would give me 25 square root of 3, or an estimated of 43.3 centimeters squared, because it's area of a triangle. Good. Let's go on to the next one. The question is, calculate the radius of a circle with a circumference of 10 centimeters. So we want to find R when the circumference of a circle is 10 centimeters. Okay, what do I know about circumference? Circumference is equal to 2 pi R. I know that circumference is 10, and I've got to solve for R. So how do I solve for R? I just divide by 2 pi on both sides of my equation. That gives me R equals 1.59. Okay, we need to keep those values. I need it for the next bits for information. Okay. So the next part 5C gives us 3 diagrams, and they give us some information about it. They say the diagram represents the net of 3 solids. Each straight line is 10 centimeters long, and they indicated that this one is 10 and 10, so that must be 10. Okay, so it's little triangles like that, and each straight line is 10 centimeters long, and each circle have a circumference of 10 centimeters. Then they ask us, name the solid whose net is diagram 1, and calculate its surface area. Okay, it is definitely a triangular pyramid. Okay, so that would be the first part of my question. And then the surface area, well, we actually have just found the surface area, the area of a little triangle that's 10 by 10. And that was 25 square root 3. But now we have 1, 2, 3, 4 of those little triangles. So we will have the surface area would be 4 times 25 square root 3. And I should have written there surface area. Okay. And that, if I do that on my calculator, I should get 100. Is that right? 4 times 25 is 100 square root 3, and that is a solid good answer. Okay. The next one is, they say, name the solid whose net is in diagram 2. Name the solid whose net is in diagram 2, and then calculate its volume. So what kind of solid would that be? I think it would be, if you look at that, 2 little circles, it would be a tube, so it's a cylinder. Okay, now then the second part is calculate its volume. We know that the volume of a cylinder is the area of a base times the height. We know that the area of a base is the same thing as what we have found in this circle, because this circle, the circumference of this circle was 10 centimeters, and it's given that the circumference of those little circles is 10 centimeters. So that area, we know that the radius is 1.59 centimeters, so we can find the area. Area would be pi radius squared times the height, and we know that the height is 10, so I can just plug that in, pi 1.59 squared times 10, and that will give me an answer of 79.4 and its volume, so centimeters cubed. Okay, the last one. Name the solid whose net is in diagram 3 and calculate its perpendicular height. Okay, so we've got to do a little bit of thinking there. We need to find its perpendicular height, the solid's perpendicular height, not the net's perpendicular height. Okay, so what kind of solid would it be? It would be a cone. Okay, and the perpendicular height would be this thing. It would look like that if we cut the cone in two. This here would be your radius, so it's 1.59. That leg over there would be part of the, it would be the slanted height, the 10 centimeters. So we want to find this bit over there. Okay, so I know we can use Pythagorean theorem. So let me just move my paper up slightly. So a squared plus b squared equals c squared. I know what is a. The value of a can be any one of those. So a squared plus 1.59 squared equals 10 squared. If I solve for a, the value of a would be 9.87. And we are basically done with question 5. Okay. Okay, let's move on to question 6. You're doing marvelously well. Just keep going. We're nearly there. Okay, I've done a little sketch there so that we can continue on our journey. They say here a rectangular base open box has external dimensions. So it's an open box, so it must just have a base, but the lid, the top is open. Dimensions of 2x centimeters, x plus 4 centimeters, and x plus 1 centimeters. Then they ask us in the first question, write down the volume of a cuboid with these dimensions. So we need to find the volume of this. We know volume equals length times base times height. The length is 2x and x plus 4 and x plus 1. And we are done. Okay. Then they ask in question 2, expand and simplify your answer. So volume would be, and I'm just going to keep that there, and then expand. So I'm just going to distribute the first bit. That would give me x squared plus x plus 4x plus 4. Let's just continue to simplify it. X squared plus 5x plus 4. And now distribute that to x. That would give me 2x cubed plus 10x squared plus 8x. And there we are. We've done it. Okay. Good. So we need to keep a box because the next question will demand us to use it. The box is made of 1 centimeter thick wood. Write down the internal dimensions of a box in terms of x. Okay, so look at that. The internal, so we know that the external is 2x. So if I'm using 1 centimeter less here and 1 centimeter less there, this dimension will change to 2x minus 2. So let's write it down. So the first one would be 2x minus 2. Okay. This one will change 1 centimeters here and 1 centimeters on that side. So it would be x plus 2. Okay. This dimension here, we will just not use the bottom 1 centimeters because, I mean, they would be now 1 centimeters thick. So that will change to x. Okay, and this is the dimension of the internal area of a box. Okay, so that's the dimensions. So the internal volume, okay, of all dimensions of a box. Okay, now let's have a look. Find the volume of the inside of a box. Show what the volume of a wood is this. So we've got to do a few things here. The volume, we have already written it down actually as x and 2x minus 2 and x plus 2. If I distribute this, I will get 2x cubed plus 2x squared negative 4x. I will do the distribution by first distributing the brackets and then multiplying the x into it. Okay. Now, that's not the volume of a wood. The volume of a wood is the external minus the internal. That would give you the volume of a wood. Okay, so the external, we know that was 2x cubed plus 10x squared plus 8x, just keep it in brackets, minus the internal volume that we've found just there is 2x cubed plus 2x squared minus 4x. Okay, let's simplify this expression. So 2x cubed minus 2x cubed will cancel one another. 2x squared minus 2x would give me 8x squared. 8x plus 4x would give me 12x. So the volume of a wood would be 8x squared plus 12x. Okay. Good question. We're still with question 5. Now if I say the volume of a wood is 1,980 centimeters cubed, show that 2x squared plus 3x negative 495 equals 0 and solve this equation. Okay, so we know that our volume, where was the volume? It was 8x squared plus 12x would be equal to 1980. Okay, I'm just going to move this term over to that side. So 8x squared plus 12x minus 1980 equals 0. I need to have a 2 here. So that means I divide this whole equation by 4. That will give me 2x squared plus 12. That will give us 3x. And 4 divided by 198 would give us negative 495 equals 0, and we are done. Okay, so sorry, we still have to solve this. Okay, I need to just continue here and solve this equation. So I'm not going to factorize this. It's a really messy thing. I'm just going to use the quadratic. Okay, b is negative 3 plus or minus 3 squared negative 4. A is 2 negative 495 all over 2. If I plug that into my calculator, I will get 2 different values. X, if I do it quickly, x equals to 15. If I use the negative, I get x equals negative 33 over 2. Well, a dimension can hardly be negative, so I'm going to use this as x equals 15. Okay, good. So then they ask us, write down the external dimensions of a box. So we do know that x is now 15, so the external dimensions was 2x, x plus 4 and x plus 1. So if it is 15, we'll get 2 15, that would give us 30. 15 plus 4, that would give us 19, and 15 plus 1, that would give us 16. So the dimensions would be 30 centimeters, 19 centimeters, and 16 centimeters respectively. Good, so that concludes question 6, and we're going really nicely, so well done. Keep it going, guys. The next question is a vector question, and they give us a star shape, a and they say a star is made up of a regular hexagon, so all these sides are equal to one another, and surrounded by equilateral triangles. So every little triangle will also be equal to one another. And that is awesome because I know this little edge would be equal to that. So all these internal edges would be equal to one another and the external ones too. Now if I say OA equals A and OB equals B. And then they give us quite a couple of things to find. So the first one is write down the following vectors in terms of A and or B, giving your answer in its simplest form. And the first one is OS. Okay, look at that. OS is O to S, and that is just A plus A plus A. And that would give us 3A. The next one is AB. So from A all the way to B. Okay, so that would be, we'll go against the traffic, negative A plus B. And that is the answer. Okay. The next one is CD. So C, I need to go from C to D, and that's the same thing as A. Okay, the next one is OR. So I'm going from O to R, and I need to travel a few roads. So it would be B plus A plus A. So OR would be B plus A plus A. That would give us 2A plus 2B in its simplest form. Then the next one is CF. Oopsie, sorry. Move it up a little bit. Just look there. C to, CF. Where's my F? E, oh, there it is. Okay, CF. So I need to travel from here, from C to F. If I do that, I will go A plus A minus B minus B. So it would be A plus A minus B minus B. That would give me 2A negative 2B. And we are done with the first part of A. Let's move on to number B. Okay. They say when the value, the absolute value of A equals 5, write down the value of the absolute value of B. Now, we've discussed this when we started. It's an equilateral triangle. This value is 5, the length. This length would also be 5 because all these little triangles would be equilateral. So all three sides would be equal to 5. So that would be 5. The absolute value of B would also be 5. Then they ask us, what is the absolute value of A minus B? A minus B is A minus B. So minus B plus A. That would be this little distance, BA. And we've already discussed it again, that these are little equilateral triangles. So if that one is equal to 5, that one is equal to 5, the equilateral triangle, this length would also be 5. So my answer for that is 5. Okay, good, let's go on. Describe fully the single transformation which maps triangle OBA onto triangle OQS. OBA onto triangle OQS. So it's the same triangle that's just been enlarged by a factor of 3. So it is an enlargement. And it's a factor, a scale factor of 3, and the center is O, or the origin. Okay, so the next one, they ask us, what is the triangle that maps OBA onto triangle RDE? RDE. So O and O will be B, O, B. B will be now on E and A will be on, B will be on D and A will be on E. So this, and I've drawn this CF on purpose therein, so that you can see that CF is like a mirror, that if I flip this triangle over, it will map directly onto it. So this transformation is reflection around CF. Okay, good. Let's see what the next question brings. Okay, how many lines of symmetry does the star have? Okay, let's quickly have a look. Lines of symmetry. There's a line 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 of symmetry. So 1, 2, and there's a line of symmetry. So that would give us 6 lines of symmetry. Okay, good. The next question. When OQS is rotated, okay, clockwise about X, it lies on PRT. Write down the angle of rotation. So OQS is rotated about the origin X, okay, but around the center X. Clockwise, it lies on PRT, So Q would move to P. And now they ask us what would be the degree of rotation. So if I look at that, we have a center O, and I'm going to rotate it to this bit, and that's the rotation that I'm looking at. So I've got 1, 2, 3, 4, 5, 6 different angles. We know it's a regular hexagon with equilateral triangles. So it means that all the rotations would be all equal to one another. If I turn right around, it would be 360. So my rotation would be 360 divided by 6. That would give me an angle of 60 degrees clockwise. And that's the answer. Okay, good. And that concludes question 7. We move on to question 8. Okay, let's read the information there. Answer this question on a sheet of graph paper, and in a survey 200 shoppers were asked how much they had spent, and the results are shown in this table, and I've quickly just written down the table for you. Okay, now that the first question says write down the modal class. The modal class is the most frequent class, and if I look at that, the 54 is the most. The class would be then 60 to 80. Okay, so that group would be my modal class. The next one is calculate the estimated mean. So estimated mean is x bar, and it's the sum of fi xi over the sum of fi. So I've just started there to write down what would be the mid-class value of each one of those groups. So the mid value there would be 10, the mid value there would be 30, the mid value there would be 50, and so forth. Okay, so fi is my frequency and xi is my mid-class value, and I'm going to be the sum of them. So it would be 10 times 10 plus 32 times 30 plus 48 times 50 plus 54 times 70 plus 36 times 90 plus 20 times 120 all over 200. The sum of fi, we said it was 200 shoppers. I tap that whole thing into my calculator, and I get a value, and if I simplify that, 64.40. Okay, so the x bar, or the mean, the estimated mean would be 64.40, and it makes sense that it will fall in my modal class, and I'm quite happy with the answer. Okay, now the next bit, the number B, is they say make a frequency, cumulative frequency table for these 200 shoppers. So there's my table. I've just written down all the information down. It's amount and then the cumulative frequency. We started off with 10. Then I add the 32 to it. That would give me 42. I add the 48 to it. That would give me 90. I add the 54 to it, that would give me 144. I add the 36 to it, 180. I add the 20 to it, it would give me 200. And I'm very happy because if my cumulative frequency is 200 and my shoppers are 200, I know that I've done a good job of it. Okay. Now they ask us for 8B2 is on a scale, using a scale of 2 centimeters to represent $20, the amount there at the bottom. Sorry, make it up a bit. A lot. Okay, the amount $20, 2 centimeters for $20, and 2 centimeters each to represent 20 shoppers. And I've done the shoppers there. So this is cumulative frequency, and this side is my amount. And now I have to draw the cumulative frequency graph on this information. So I'm just going to do that. So my first one at 10, I have 20. At 40, I have 42. At 60, I have 90. At 80, I have 144. Okay. At 100, I have 180. And at 140, I have 200. Okay. So that would give me one smooth curve. And I will leave my curve just as it is, one smooth curve, and I'm quite happy with that. Now they ask us using this curve to answer the following questions. Guys, you're doing really awesome. Okay, so the first one is the median. The median is the middle number. Okay, let me just change with a pen. The middle number, so it's a half of n. That would give me a half of 200. That gives me the 100th number. Okay, if I look down on the what is my 100th number there, I get something. Well, my grid could be a little bit skew there, but about 65 or 68. Okay, so I get, oh wow, could be about 64 there if I look at it quite a little bit neater, about 64. Okay, good. Then the upper quartile, my upper quartile is just 3/4 of n. That would be 3/4 of 200. That would give me 1/50th number. The 150th number, so there's 140, there's 150, and you have to look it down there. And if I look down, according to my grid, it looks a little bit more, but it's about 82. Okay, so 82 would be the answer. Okay, the next one is the interquartile range. My interquartile range we know is Q3 minus Q1, interquartile range. We've already got the Q3, that would give me 82. That's the upper quartile. Then Q1 is just a quarter of n. That it would give me the 50th number. If I read down what is my 50th number on my scale, on my grid, it would give me, I seem to find it's like 41, okay, but let's just double check there. 40, 50. Yeah, it seems like it's right, about 41, okay, and I do the calculation. That would give me 41 as an answer for my interquartile range. Now they ask us at least $75. So, sorry, how many shoppers spent at least $75? So we will have to work out again. $75 is about here. We'll have to move back and then across there, and that would be my value. And if I look at that from my grid, it looks about 120, 115. Okay, so that would be 115 shoppers, but I've spent at least $75. No, wait a bit, at least $75. So that would be 115, that's not true, sorry guys. 115 shoppers, so it's 200 shoppers minus the 115. That would give me the amount that spent at least $75, more than $75. So 200 minus 115, and that would give us 85. That's much better. So 85 shoppers that have spent at least $75. Okay, good. We're moving on at a nice tempo. I'm very happy with for you guys. We're at the last question. Okay, we're nearly done. Okay, question 9 says, well, there's a diagram 1, 2, 3, and diagram 4. Diagram 1 shows a triangle with its base divided into the ratio 1 to 3. Ratio. Please read ratio. Okay. Diagram 2 shows a parallelogram with its base divided into the ratio 1 to 3. A diagram 3 shows a kite with a diagonal divided in the ratio 1 to 3. And diagram 4 shows two congruent triangles and a trapezium at each height of 1 unit. So 1 unit, 1 unit, 1 unit. Okay, now each with a unit of 1. Okay, so let's have a look. For question 1, it says for each of the 4 diagrams, write down the percentage. So it's the percentage of a total area which is shaded. So I could divide this into 3 equal parts. That would give me 1, 2, 3, 4. So I've shaded a quarter of that. So that is 25%. Okay. Then here, this base is divided into 3. So I could do that and do that. So that's all the little triangles that I will get from here. So I will have 1, 2, 3, 4, 5, 6, 7, 8 triangles. I've shaded 1 of the 8 triangles. So 1 out of 8. If I change that to percentage, that would give me 12.5%. Okay, here this is 1 to 3, so this part could be divided into 3 little triangles, and that's 1 little triangle. So where is my little question there that I've done? Okay, that would give me, that's 3 little triangles, so that would give me 3, 4, that would give me 8 triangles. I've shaded 3 of them. That would give us 3 out of 8, and if I do that as a percentage, it would be 37.5%. The next one there, I have little triangles, so 1, 2, and this is the base, and it's 3 times, so I can divide it like that. So 1, 2, 3, 4, 5 parts, and I've shaded 3 of them, so it's 3 out of 5 parts, and I'm times it with 100 to get a percentage, and that would give me 60%. Okay, good. So the next question, and we're on the Honse start, so we're nearly done. Diagram 5, 6 and 7. Diagram 5 shows a semicircle with center O. Diagram 6 shows a circle with a radius of 1. So this is 1 and that one is 5. So that little bit is a radius of 1 and 5. And then diagram 7 shows two sectors with center O with a radius of 2, and that last little bit is 1, so that gives us that bit as 3. Remember, it's still ratio. Okay, the question started with ratios. For each of a diagram 5 and 6, write down the fraction. So we're looking at the fraction of a total area which is shaded. So the first one, I can see that I've shaded that little segment there. This is 80 degrees and 80 degrees. So I know it is 180 minus 2 times 80. That would give me 20 degrees. It is 20 degrees over a total amount of 180 degrees. It's 2 over 18 or 1/9. Okay, and that's what they wanted. They want it as a fraction, and I'm done. Question 6 says, well, what is the ratio of a shaded area? I know it is radius over radius. So it would be 1 radius is in terms of squares. Okay, so it's pi radius squared. Remember, let's just do that. Pi radius squared over pi radius squared. We know pi and pi can cancel out, so it would be 1 squared over 5 squared. That would give me 1 over 25. And we are done with 6, question 6. Diagram 6, and we're left with diagram 7. And for diagram 7, we also need to find what is the ratio of the shaded area. Okay, now here we have to think a little bit. It is the formula there. It's the radius would still be in terms of radius, so it's radius squared. Okay, but it's the full one minus the little part, the little radius there would give me the shaded area. Okay, so it's this big part minus the unshaded part would give me the shaded part for the numerator. So it's 3 squared minus the 2 squared. Okay, and if I do the calculation there, I get 5/9. Good, ladies and gents, that concludes this paper. I hope you have a fantastic midterm break. Complete it, please, and hand it in for me on Monday when we return. Thanks. Bye-bye.